What's up, scholars? We are back, and we are back with more amazing science. Today, we are still talking about circuits. Yes, we are. The circuits that allow everything to get energy. Like our lovely cell phones that we stay on all day long, way too much, and our video games like Fortnite and everything, our PlayStation 4s, our Xbox One, they all use circuits. They all use circuits. They all use circuits. You have to get used to it. They all use circuits. They take electrical energy and they change it into another kind of energy that we love. We change it into sound energy, they change it into light energy, they change it into sound energy, and we enjoy it, we enjoy it, we enjoy it, we enjoy it, we enjoy it. They change it into thermal energy. Whenever we have our little heaters there and the electrical energy is warming our little hands, and they turn it into mechanical energy whenever we have certain things that we use that involve movement. All right, so we have our circuit here. We know our parts to our circuit: our battery, our wire, our switch, our light to produce light energy, another wire. We know that our circuit needs to be closed, so we know that it's open right now because the light bulb is off. It's not producing light energy. So I know that if I close my switch, that the evidence that it's closed is that I can now see my light bulb shining, right? If it's shining, that means that the energy is flowing. If the energy is flowing, we know that the circuit is closed. If it's open, it's broken. If it's closed, it flows. Absolutely. Thank you for joining in right there. I really appreciate you. So what we're going to look at today is we're going to look at some materials that might assist in conducting or insulating energy in a circuit. It's a really easy way, and you can do this at your residence, is you can get all kinds of random things, or you can do it in your classroom. For example, I can take this paper clip and I can stick it right there on my wire, and the metal is touching the metal, and I can test to see if this paper clip is a conductor or an insulator. It's really, really easy. All I have to do is touch it to the other side of the battery and see what happens. And if you notice, my light bulb lights up. That means that this paper clip is allowing the energy to flow through it easily. And remember, we call that a conductor. Exactly. Now we can continue to test other objects of other material types. So this is a plastic fork, or not a fork, this is a plastic knife that we're very familiar with. I can take my plastic knife, I can clamp it just like that. I can touch it to my battery, and then I can observe what happens. So if the light bulb does not light up, I know that my plastic knife is an insulator. So my metal paper clip was a conductor, and my plastic knife is an insulator. And we can continue to go through different materials. Let's test this wood stick, popsicle stick. Stick it in your mouth all the time, right? Yeah, you big suckers on it and stuff. I love it. So we're gonna stick our wood stick there. We are gonna touch it on the edge, and I see nothing, so that means that it is a, what do you think? One word flows through easily, another word stops the energy. It is an insulator. Insulators keep the energy in. They do not allow it to flow through easily. So the wood popsicle stick is an insulator. Let's look at a couple more items before we hop off of here. What about a metal nail? This is a big old metal nail. You see metal nails everywhere. You see them on construction sites. Sometimes you'll see them hammered into doors at our residences, or you might only see the tip of the head right there. That's a metal nail. So I'm going to take it, I'm going to clap it, and we're going to touch it. Let's see what happens. What do you think is going to happen? What do you think? Okay, conductors, hold up a 1. If you think it's going to be an insulator, hold up a 2. If you think it's a conductor, hold up a 1. If you think it's going to be an insulator, hold up a 2. You got it? Okay, here we go. Ooh, it is a 1. It is a conductor. It allows the energy to flow through easily, and I can see that because my light bulb is turning on. Okay, let's try a couple more objects. What do I want to try? Let's try a plastic spoon. These are the spoons we eat cereal with in the mornings for breakfast. So you know you touched this plastic spoon before. Let's see if this plastic spoon is an conductor or a insulator. Here we go. I'm going to clap it and touch it, and nothing. So that means it is an insulator. Absolutely, it is a number 2, an insulator. What else do we have? Ooh, let's do this. What about a glass marble? Everybody plays with marbles, or we used to. When I was growing up, we did. I don't know if you do anymore, but this is a marble. I know you know what a marble is. And if you don't, this is a marble. We're gonna take the marble. This one's gonna be a little bit more difficult. I'm gonna hold it there, and I'm just gonna touch it. If you think it's a conductor, do a 1. If you think it's an insulator, do a 2. Conductor, 1. Insulator, 2. And Oh, nothing. It is a number 2. It is an insulator. This glass marble does not allow electrical energy to flow through it easily. So that's a good thing. And, oh, here's something you're very familiar with. A wooden pencil. A wooden pencil. We're actually going to test this one twice. First, we're going to test the wooden part of the pencil, but then we're going to test, see how it's got this metal backing right there? We're going to test that metal backing. So first, let's start with the wood. Grab it. Clamp it. See. Okay. Conductor, 1. We think it's going to be an insulator. 2. Cast your votes. Are we ready? Okay, here we go. And, oh, nothing. Nothing at all. So the wood portion of the pencil is an insulator. It's number 2. The wood portion of the pencil is an insulator, materials that do not allow electrical and thermal energy to flow through it easily. But let's test this metal part at the back and see what happens. So I'm just going to stick that there like that. Then I'm going to take this and I'm just going to touch it on the ends. Oh, we've got lights. You see it? Yes. Okay. So this is an interesting. So the wood portion of the pencil is an insulator, number 2. The metal portion at the back is a number 1. It's a conductor. So we're starting to notice some differences between the types of material and whether they are insulators and or conductors. Let's try something really long. Let's try a metal spoon, really long metal spoon. So I'm going to clap this all the way at the bottom. Okay, I wonder if length has something to do with it. So if you think it's a conductor, do number 1. If you think it's an insulator, do number 2. Are we ready? Okay, here we go. 5, 4, 3, 2, and 1. Whoa, look at that. It is a conductor. We've got electrical energy flowing through it, scholars. I knew y'all knew it because y'all so smart. You're just so smart. You'll be doing all kind of good stuff. All right, we could do like Morse code. There we go. All right, scholars, we have looked at so many different materials today. We've looked at a plastic spoon that are insulators. I'm going to stick my insulators in this hand. We looked at a wooden popsicle stick that was an insulator. We looked at the wood portion of a pencil that was an insulator. And we looked at a plastic knife that was an insulator. I want you to ask yourself today, what are the similarities that we see between our insulators? What are the similarities that we see between our insulators? Okay, so what conductors did we find? As a conductor, we found a metal nail, we found a metal paperclip, and we found a metal spoon. And I want you to ask yourself the same question. What are the similarities that you notice between your conductors? And then the last question is, what are the differences that you've noticed in the material base between our conductors and our insulators, between our conductors and our insulators? And see if we can find any patterns or any trends or any things that we might be able to acquire by looking at the materials that are there. You guys are amazing. That was 8 minutes of greatness. We discovered conductors and insulators. We got a quick little review of circuits. We remember that a circuit is a complete path through which electrical energy can flow, that when it's open, it's broken, when it's closed, it flows. And then we've also looked at different types of materials that might either allow or hinder. Hinder means to stop, or insulate. Allow means to conduct the flow of electrical energy through a circuit. Scholars, y'all are awesome. Hope y'all had an absolutely wonderful time, and we will be back on soon with more amazing science.